This is BC Chapter 7 review. Let's look at number 1 here, which says find the area bounded by the graph y equals negative sine of x. So here's negative sine of x, goes through the origin, but instead of in the first quadrant for pi over 2, it's actually going to be flipped around. It's going to be the reflected version of y equals sine of x. We have also y equals cosine of x, which will hit the has y-intercept at 1, and will cross also with the negative sine of x at negative pi over 4. We're trying to find the area bounded between negative pi over 2 and pi over 2. So if we can sketch this graph, we can see that there's going to be two separate regions that we have to find the area separately for, since there's an intersection between the two graphs. So that means there's going to be a change in the top and bottom function, so we can't just rely on one definite integral to find the area of these two regions. So the first, first off, we should know that there's going to be an intersection that where the graph will cross somewhere between negative pi over 2 and pi over 2. And the way we find that is we set negative sine of x equal to cosine of x. And really, we can think of sine and cosine can combine to be tangent. So if I divide both sides by cosine of x, I get negative sine over cosine is equal to 1. Move the negative 1 over, sine over cosine equals negative 1. And then we know sine over cosine is tangent. So tangent is negative 1 at 3 pi over 4 and 7 pi over 4, or basically variations of pi over 4 in the third and first quadrant. Actually, negative 1. Sorry, negative 1 is going to be in the first, second, and fourth quadrant. So 7 pi over 4 is the same thing as negative pi over 4 if we're looking at in terms of this graph. So we know the graph will cross at negative pi over 4. The two graphs will intersect at negative pi over 4. So we can think of this as top minus bottom. So the first region, top minus bottom, will be negative sine x minus cosine x from negative pi over 2 to negative pi over 4. So that's my first definite integral. Plus, so that this is the left area region. The right area region will be from negative pi over 4 to pi over 2. Sorry, the graph should have, pi over 2. Even though they intersect further, we only care about up to pi over 2. So negative pi over 4 to pi over 2 of the cosine x minus the negative sine x. So that's why careful with the two negatives there. And then if we just work that through, this will give us the area. Use our calculator to find the area of those two regions. Okay, number 2, find the volume of the solid generated by revolving the region bounded by x equals 4 minus y squared, x equals 1 in the x-axis. So we have to first figure out where this region is. Okay, so the region, if we think about x equals 4 minus y squared, maybe it's difficult to visualize what this graph looks like. But if we solve for y, we can know that y is equal to root 4 minus x. So there's going to be an x-intercept at x equals 4, and then the graph is going to open to the left. So this is root 4 minus x. This is negative root 4 minus x. Okay, so essentially 4 minus y squared, it's going to be a sideways parabola that opens to the left with an x-intercept at 4. Okay, so that takes care of the curved region. X equals 1, that's a vertical line here. Okay, and the x-axis. Okay, so the way that we did this problem here, we didn't include the x-axis. Okay, the x-axis is not one of the boundaries. So we're doing the entire region here. About the line x equals 1. So notice that this graph is right up against the line x equals 1. So we know we can use this method, but since it's a vertical line, we have to do right minus left. We have to draw a horizontal radius. So right minus left, the right curve is 4 minus y squared. The left curve is 1. So right curve minus left. And then if we set the two equations equal to each other, the 4 minus y squared equal to x equals 1. set them equal to each other, we can solve for y. Y is negative root 3 and positive root 3. So from negative root 3 to root 3, pi radius squared will be the formula for this method. So squared there. And then that simplifies to be quantity 3 minus y squared quantity squared. Okay. All right. And then if we want to find the volume, we can just enter that into our calculator here. All right. About the line x equals 4. So it's the same shaded region, but now it's up against x equals 4. Notice that if we have a curved region up against an axis of revolution, we know that there's a gap. Because of the gap, we have to go through washer method. So again, we know it's a vertical axis, so our radius will be horizontal. So if it's horizontal, we have to do right minus left. Big R will extend from the axis to the further boundary of the shaded region. Little r will extend from the axis to the closer boundary of the shaded region. So then we do right minus left. So this is going to be 4 minus 1. So that's going to be big R. Little r will be 4 minus the curve, which is 4 minus y squared. And then we have washer method. Pi big R squared minus little r squared. So big R squared is 3 squared. Little r squared is y squared quantity squared. And then from the lowest to the highest y value have to be in terms of y. So negative root 3 to positive root 3. Okay, let's look at the back page here, number 2. Find the volume of the solid generated by revolving the region about x equals 4 minus y squared. So it's the same graph here. Here's the curve, here's x equals 1, here's the shaded region. But now we're rotating about the line x equals negative 1, but we want to use the shell method. So the shell method, we have to find the distance from the axis to a point that is on in the curve. So the shell radius will be 1 plus x, and x will be the distance from the axis to any point that is in the shaded region. Okay, so 1 plus x will be the shell radius from the axis to any point on the curve. And then the shell height will be top minus bottom, so also it has to be in terms of x. So we know that this is root 4 minus x. We know this bottom is negative 4 minus x. So top minus bottom will be root 4 minus x minus a negative root 4 minus x. Combine those two to be 2 root 4 minus x. And then everything's in terms of x, so our bounds are also in terms of x. Our boundary is only for the shaded region, so from x equals 1 to x equals 4. And then we use our calculator to also find our volume. Okay, part D. The region represents the base of a solid, so we're using the same region here. Okay, the cross section is isosceles right triangles perpendicular to the x-axis. So here's the x-axis. Perpendicular will be vertical. So if we want to do vertical base, we do top minus bottom. So root 4 minus x minus negative root 4 minus x. So the base will be 2 root 4 minus x. We want this base to represent the leg of the isosceles right triangle. So we know that if this represents the base, the area of this cross section will be 1/2 base squared. So 1/2 base squared. And then from our boundaries will be from 1 to 4 in terms of x. And then we just do that as a setup and then just use our calculator to find the volume. With hypotenuse on the base of the solid, so now we want a triangle where this is lying on the base. And the formula for hypotenuse on the base of the solid is going to be 1/4 base squared. Okay, so 1/4 base squared from 1 to 4. So here's our setup. Part C, trapezoid with one base on the solid. The other base is twice the length of the base of the solid. So the area of a trapezoid is height over 2, b sub 1 plus b sub 2. Okay, so we know the height is 5, so 5 over 2. And then the two bases, one base is going to be the 2 root 4 minus x, we know that. The other is going to be twice the length of that, so twice the length of that will be times 2, which will then be 4 root 4 minus x. So here's our formula. Height over 2, b sub 1 plus b sub 2 from 1 to 4. And then we also use our calculator to find the volume there.